The objective of this first chapter is to review takeoff weight limit issues created by declared distances, discuss the runway safety area concept, and look at some possible FMS issues. A critical piece of data in determining your takeoff weight is the usable runway length. But if an airport publishes declared distances, the usable runway length may differ from the pavement length, which can lead to errors in departure planning. The widespread use of declared distances stems from the introduction of the Runway Safety Area Program in 1999. This program is scheduled for completion by 2015 and aims to reduce injury and aircraft damage during overruns, undershoots, and veer-offs. This increased safety is accomplished by requiring airports to establish larger safety margins around its runways. A better runway safety area in Teterboro would have prevented or at least minimized the devastation of this overrun accident in 2005. Because of high-profile incidents like this and the 2015 deadline, many airports are scrambling to establish appropriate safety areas. Runway safety areas, usually referred to as RSAs, are based on accident statistics about overrun and excursion events. For example, the majority of aircraft involved in overruns come to rest within 1,000 feet of the runway. Consequently, the RSA program requires that all Part 139 airports establish 1,000 feet of RSA beyond the end of the runway. This 1,000-foot safety area doesn't have to be paved, but it does have to be level, drained, and graded to support the weight of a typical aircraft and emergency vehicles in the event of an overrun. Airports which have enough open ground around their runways can typically use this land as their RSA. However, airports in confined areas often run into problems complying with the runway safety area requirements. One option is to declare that only a portion of the pavement is usable for takeoff planning, leaving the remainder to serve as the RSA. Before we go any further, let's sort out the terminology and then we'll get into the operational considerations. There are 4 declared distances: takeoff run available, takeoff distance available, accelerate stop distance available, and landing distance available. These are often referred to by their abbreviations TORA, TODA, ASDA, and LDA respectively. You'll also see the terms clearway and stopway. A stopway is an area beyond the takeoff runway controlled by the airport and able to support the airplane during an aborted takeoff without causing structural damage to the plane. A clearway is an area of airspace beyond the takeoff runway, again controlled by the airport and intended for the completion of a takeoff following an engine failure. However, the only way to account for a clearway is to use unbalanced takeoff data. Since Tyson Aviation uses only balanced field length calculations, this won't impact your departure planning. That said, it's worth noting that, unlike a stopway, the surface area under a clearway need not be suitable for stopping after an aborted takeoff. Accelerate stop distance available, or ASDA, is the runway length plus stopway declared usable and suitable for the acceleration and deceleration of an aircraft rejecting a takeoff. The ASDA may be longer than the physical runway when a stopway has been designated, but the ASDA may be shorter than the physical runway when local geography forces the airport to use some of the pavement for their RSA. Takeoff run available is the distance suitable for the ground run of a departing aircraft. This number is typically the length of the pavement, but again, it may be shorter if some of the pavement has been designated as a safety area. Takeoff distance available is the takeoff run plus any clearway. Since clearways don't apply to our operation, TODAs won't either. Landing distance available is probably the most familiar because it's associated with displaced thresholds, and we'll cover that in the module on landing performance. Declared distances introduce a handful of operational considerations you need to be aware of. First and most importantly, declared distances can shorten the amount of runway available for takeoff planning. Second, declared distance information is only published in the airport facility directory and NOTAMs. Having said that, AirInc Direct accounts for declared distances in their planning package. Third, the FMS contains only the pavement length. not the declared distance information, and we'll get to more on that in just a moment. Thus far, Jeppesen has not incorporated declared distance information. However, they do provide explanatory notes when the usable runway is shorter than the pavement length. If you're using NOS plates, an inverted D indicates that the airport publishes declared distances. Finally, declared distances only affect planning. During line operations, you can use any pavement that's marked as usable runway. Let's take a look at a couple of quick examples of how declared distances can come into play. At XNA, the official declared distances are equal to the runway lengths in all cases. This simply means that the airport has adequate runway safety areas around all runways. Smaller airports like Springdale, who do not have air carrier traffic, have reduced RSA requirements and typically don't use declared distances. However, during construction or partial runway closures, as shown here, the airport manager will use declared distances in the associated NOTAM. If we look at an airport like Cobb County, Georgia, we can see an example of declared distances being used to achieve the required RSA during regular operations. The physical length of runway 27 is 6,311 feet, but the accelerate stop distance available is only 5,374. This is because Highway 41 runs so close to the end of runway 27 that the airport had to use the last 937 feet of pavement for their runway safety area. What this means is that 5,374 must be used as your runway length for takeoff planning. However, if we load KRYY into the Collins 6100 FMS, the runway length shows up as 6,311, not 5,374. In this situation, if you allow the FMS to calculate performance data, based on this value, you could generate erroneous takeoff numbers. Also, in this example, you're likely to see a disparity between the FMS numbers and the AirInc Direct numbers. Since the shorter accelerate stop distance available is the limiting factor, you may want to update the FMS to reflect that. Section 618 in the Collins FMS 6100 Operator's Guide will take you through this process in detail, but the basic steps are to press the Performance key and call up the Performance menu. Push the Takeoff Line Select key to display one of the 4 takeoff performance pages. Use the Line Select key for runway length to manually revise the data. Notice that manually entered data is displayed in a larger font than the FMS-generated data. Once all the appropriate information is loaded, the new performance numbers from the FMS should come much closer to agreeing with the APG performance package. Runway safety areas differ by airport. Class 1 airports with air carrier operations, like XNA, have larger RSA requirements and are required to publish a declared distance for every runway, even if these distances are identical to the pavement length. Smaller Class 2 airports, like Springdale, have reduced RSA requirements. If no declared distance is published, simply use the runway pavement length for takeoff planning. If declared distances are published, you'll likely want to use the more conservative of the TORA or ASDA. As the Runway Safety Area program nears completion in 2015, you can expect to see more airports publishing declared distances and more discussion about their use in everyday flying. Let's take a quick look at Chicago Midway, an airport famous for geographic constraints. Surprisingly, the declared distances are equal to the physical length of the runway, displaced thresholds notwithstanding. How is this possible with adjacent roads on all sides? The answer is EMAS, or Engineered Materials Arrestor System. These energy-absorbing materials, basically lightweight concrete blocks, crush under the weight of an aircraft. This high-speed quicksand stops the aircraft and prevents overruns, usually with little or no damage to the airplane. If an airport chooses to install an EMAS arresting barrier, they're granted relief from certain RSA requirements. Following the 2005 Challenger crash at Teterboro, the Port Authority installed several EMAS systems, and in 2010, one of those systems prevented a Gulfstream 4 from becoming another overrun accident.
The private Gulfstream plane with 7 passengers and 2 pilots on board overshoots the runway, slamming into the airport's arrestor bed, the plane stopping just yards away from busy Route 46. Chopper 2 HD over the scene just after 2 o'clock. No one on the ground injured, no one on board the plane injured, likely thanks to the arrestor bed barrier. It's made of specially designed air-rated cement blocks. Airport authorities say the barrier did just as it was designed, stopping the plane in its tracks, protecting the passengers and crew on board and the innocent drivers on Route 46.
With the basic concepts in hand, let's listen to an interview with Phil Brown, Director of Aviation for McAllen International Airport, to see just how much impact the Runway Safety Area program is having in the decision-making process at airports across the country.
McAllen Airport officials have looked at as many as 20 alternatives to meet new runway standards required by the Federal Aviation Administration. It involves having a designated runway safety area at the beginning and end of the runway to accommodate planes that undershoot or overshoot the runway.
I think it's important that, people understand that this is a safe airport and we are safe. We met the standards when the airport was built. The FAA changed the standards and now they're causing all the airports to come in compliance with the new standards that were put into effect in 2005.
To comply with the new standards, a runway safety area study was conducted.
And we looked at 20 different alternatives. And we started out by looking at alternatives to say, okay, what can we do if we don't add any pavement, if we don't change anything? If we don't add any pavement, what can we do? And then we went all the way up to alternatives that are fairly expensive, that if we added what is called EMAS.
EMAS is a high-energy absorbing material proven effective in stopping planes that overrun the runway. The material crushes under the weight of the aircraft.
Now the bottom line is, if we don't do anything, if we decided we're not going to spend any money, we're not going to do anything, the FAA then would require us to relocate our thresholds. Instead of having an end of a runway here, we'd have to have an end of a runway somewhere down here. Instead of having an end of a runway here, it'd have to be in here somewhere.
After looking at all their options, Airport Director Phil Brown and his team suggested 2 options that might be the best fit for McAllen International.
One is an alternative that allows us basically to use what we have here, do declared distances, and spend a couple $1 million. We lose a little bit of runway. We go down to, on the runway 31, 6,940 feet instead of 7,120. On runway 13, we keep the 7,120 as far as takeoff distance available, but we lose a little bit on landing distance available. And that's a relatively inexpensive $1.3 million fix.
The other alternative is a $10 million fix with more benefits for the airport. It includes installing EMAS.
By putting what we call engineered material arresting system down here, we can actually, in effect, increase the length of our runway. Because when you put that, it's called EMAS. When you put that EMAS down here, it's concrete that when an airplane goes on it, it crushes and it'll sink in and it'll stop the airplane. And so by putting 300 foot of EMAS down here, it has the effect of acting like 1,000 foot of safety area.
Essentially, more runway translates to farther destinations for airlines. McAllen Airport officials will present the latter proposal to the FAA. I'm Ray Pedraza, and this is the McAllen Cable Network.
Now let's move on to the next chapter and take a close-up look at the difference between certification requirements and procedural design.